The National Electrical Code, or NEC Article 300.4 addresses the protection of conductors for general wiring. It mandates that conductors should be enclosed in raceways except as specifically permitted in sections 300.4d through 300.4g. Article 300.4d specifically deals with open wiring on insulators. This section requires that open conductors be supported on insulators and maintain a minimum clearance of 2 inches from any combustible material. Furthermore, all conductors must be adequately protected from potential mechanical damage. Article 210.52 ATWO states that outdoor conductors that are subject to physical damage must be installed in a raceway to ensure their protection. The National Fire Protection Association, or NFPA 54, which pertains to the National Fuel Gas Code, specifies requirements for gas vent pipes. Section 3.17 of NFPA 54 mandates that vent pipes must be installed with a minimum clearance of 12 inches from electrical wiring, or more if required by specific local codes. Considering these codes, let's address the 2 specific scenarios regarding 12-2 Romex wiring. Firstly, exterior wiring. It is not permissible to run 12-2 Romex on an exterior above 8 feet between the vertical face of a house and a Grade B gas vent pipe. The primary reason is the minimum clearance requirement between electrical wiring and a gas vent pipe, which is specified as 12 inches according to NFPA 54, Section 3.17. This clearance is essential to prevent any potential electrical hazards due to the proximity of electrical wiring to gas vents. Secondly, wiring through a stucco ceiling. It is permissible to run 12-2 Romex through a stucco ceiling to a connecting circuit, provided that certain conditions are met. These conditions are: firstly, the conductors must be properly supported on insulators, ensuring they are not closer than 2 inches from any combustible material, as stipulated by NEC Article 300.4d. Secondly, the conductors must be protected from mechanical damage to ensure the integrity and safety of the wiring. In summary, the installation of 12-2 Romex wiring, whether on an exterior or through a stucco ceiling, must adhere strictly to the guidelines provided by the NEC and NFPA 54 to ensure safety and code compliance. The 12-inch clearance from gas vents is paramount in exterior installations, while proper support and protection from mechanical damage are critical when running wiring through stucco ceilings. To elaborate further on NEC Article 300.4, this section is crucial for understanding the proper methods for protecting electrical conductors. The requirement for enclosing conductors in raceways serves several purposes. Firstly, it provides physical protection against impacts, abrasion, and other forms of mechanical damage. Secondly, it helps to contain any potential electrical faults, such as short circuits or ground faults, reducing the risk of fire or electrical shock. Thirdly, it offers a degree of environmental protection, shielding conductors from moisture, dust, and corrosive substances. The exceptions listed in 300.4d through 300.4g allow for specific situations where conductors may be installed without raceways, but these exceptions come with their own set of requirements to ensure safety and proper installation. Open wiring on insulators, as detailed in Article 300.4d, is one such exception. This method involves supporting conductors on insulators, which are typically made of porcelain or glass. The insulators keep the conductors separated from each other and from any surrounding surfaces, preventing electrical leakage and reducing the risk of short circuits. However, open wiring on insulators is subject to several limitations. The conductors must be securely attached to the insulators, and the insulators must be firmly mounted to a supporting structure. The conductors must also be kept at least 2 inches away from any combustible materials, such as wood or paper, to prevent the risk of fire. Furthermore, the conductors must be protected from mechanical damage, which may involve installing them in a location where they are not likely to be struck or damaged, or providing additional physical protection, such as a guard or shield. NEC Article 210.52 ATWO specifically addresses outdoor conductors and their susceptibility to physical damage. Outdoor environments can be harsh, with conductors exposed to sunlight, rain, wind, and temperature extremes. These conditions can degrade the insulation of conductors over time, making them more vulnerable to damage. Additionally, outdoor conductors are more likely to be struck by objects such as tree branches, vehicles, or even vandals. To protect outdoor conductors from these hazards, the NEC requires that they be installed in a raceway. A raceway is an enclosed channel designed to hold and protect electrical wires and cables. Common types of raceways include rigid metal conduit, electrical metallic tubing, and PVC conduit. These raceways provide a physical barrier that shields the conductors from damage and helps to contain any potential electrical faults. NFB 854, Section 3.17 addresses the importance of maintaining adequate clearance between gas vent pipes and electrical wiring. Gas vent pipes are used to exhaust combustion gases from appliances such as furnaces, water heaters, and boilers. These gases can be extremely hot and may contain flammable or explosive substances. If electrical wiring is installed too close to a gas vent pipe, the heat from the vent pipe can damage the insulation of the wiring, increasing the risk of electrical shock or fire. Additionally, if there is a gas leak in the vent pipe, the gas could ignite if it comes into contact with a spark from the electrical wiring. To prevent these hazards, NFPA 54 requires that gas vent pipes be installed with a minimum clearance of 12 inches from electrical wiring. This clearance provides a buffer zone that reduces the risk of heat damage and prevents the ignition of flammable gases. It is important to note that some local codes may require even greater clearances, so it is always a good idea to check with the local authorities before installing any gas vent pipes or electrical wiring. Now let's delve deeper into the specific requirements for wiring through a stucco ceiling. Stucco is a type of plaster that is commonly used on the exterior of buildings, but it can also be used on interior walls and ceilings. Stucco is relatively durable and fire resistant, but it is also somewhat porous and can absorb moisture. When running electrical wiring through a stucco ceiling, it is important to take precautions to protect the wiring from moisture and physical damage. One way to protect the wiring is to install it in a raceway. A raceway provides a physical barrier that shields the conductors from moisture and prevents them from being damaged by the stucco. Another way to protect the wiring is to use conductors that are specifically designed for use in wet or damp locations. These conductors have a special insulation that is resistant to moisture and corrosion. In addition to protecting the wiring from moisture, it is also important to ensure that the wiring is properly supported. The conductors should be securely attached to the ceiling using appropriate fasteners such as staples or clamps. The fasteners should be spaced close enough together to prevent the conductors from sagging or coming into contact with the stucco. If the conductors are not properly supported, they could be damaged or could pose a safety hazard. To summarize, when running electrical wiring through a stucco ceiling, it is important to take precautions to protect the wiring from moisture and physical damage, and to ensure that the wiring is properly supported. This will help to ensure the safety and reliability of the electrical system. Furthermore, it is essential to comply with all applicable codes and regulations, including the NEC and NFPA 54. By following these guidelines, you can ensure that your electrical installations are safe, code compliant, and reliable. In addition to the above points, it is crucial to consider the ampacity of the 12-2 Romex wire. According to the NEC, 12-2 Romex typically has an ampacity of 20 amps when used in residential wiring. This means that it can safely carry up to 20 amps of current without overheating. It is important to ensure that the circuit breaker or fuse protecting the circuit is also rated at 20 amps or less. Using a higher rated circuit breaker or fuse could allow the wire to be overloaded, which could lead to overheating and a potential fire hazard. Also, consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. This can be caused by the resistance of the wire and the amount of current flowing through it. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. The NEC provides guidelines for calculating voltage drop and recommends that the voltage drop in a branch circuit should not exceed 3%. When running 12-2 Romex over a long distance, it is important to calculate the voltage drop to ensure that it is within acceptable limits. If the voltage drop is too high, you may need to use a larger wire size or install a separate circuit closer to the load. Another important consideration is the proper grounding of the electrical system. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source in the event of a short circuit or ground fault. Proper grounding helps to protect people from electrical shock and can also prevent damage to electrical equipment. The NEC requires that all electrical systems be properly grounded, and it specifies the methods for achieving proper grounding. When running 12mm2 Romex, it is important to ensure that the grounding conductor is properly connected to the grounding electrode system. The grounding conductor should be the same size as the circuit conductors, and it should be securely connected to all metal enclosures and equipment. Finally, remember to always disconnect the power before working on any electrical wiring. This is the most important safety precaution you can take to prevent electrical shock. Before starting any electrical work, turn off the circuit breaker or remove the fuse that protects the circuit you will be working on. Use a voltage tester to verify that the power is off before touching any wires or terminals. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Electricians have the training and experience to safely and properly install and repair electrical systems. In addition to the NEC and NFPA 54, there may be other local codes and regulations that apply to electrical wiring in your area. It is important to check with the local authorities to ensure that you are complying with all applicable codes and regulations. Failure to comply with these codes and regulations could result in fines or other penalties. Proper electrical wiring is essential for the safety and reliability of any building. By following the guidelines and recommendations outlined above, you can help to ensure that your electrical installations are safe, code compliant, and reliable. Remember to always prioritize safety and to consult with a qualified electrician if you have any questions or concerns. Furthermore, regarding the stucco ceiling, it's important to consider the type of stucco. There are various types, including traditional stucco and synthetic stucco, each with different properties. Traditional stucco is typically made from a mixture of cement, sand, and water, while synthetic stucco may contain acrylic polymers or other materials. The type of stucco can affect the way it interacts with electrical wiring and the potential for moisture absorption. Therefore, it's essential to identify the type of stucco before running any wiring through it. Also, remember to seal any penetrations through the stucco ceiling to prevent moisture from entering. Use a suitable sealant that is compatible with both the stucco and the electrical wiring. This will help to protect the wiring from corrosion and ensure the longevity of the electrical system. In addition, consider the environmental conditions in the area where the wiring is being installed. If the area is subject to high humidity or extreme temperatures, it may be necessary to take additional precautions to protect the wiring. This could involve using conductors with a high temperature rating or installing additional insulation to prevent condensation. And always keep accurate records of any electrical work that you perform. This includes documenting the type of wiring used, the location of the wiring, and any modifications that were made to the electrical system. These records can be helpful for future maintenance and repairs, and they can also be useful for complying with building codes and regulations. Furthermore, it's important to stay up to date on the latest changes to the NEC and other applicable codes and regulations. The electrical industry is constantly evolving, and new technologies and materials are being developed all the time. By staying informed about the latest changes, you can ensure that your electrical installations are safe, code compliant, and efficient. Consider attending training courses or workshops to learn about new electrical techniques and technologies. There are many organizations that offer continuing education courses for electricians and other electrical professionals. These courses can help you to expand your knowledge and skills and to stay ahead of the curve in the electrical industry. Finally, always remember that electrical safety is everyone's responsibility. By taking the necessary precautions and following the guidelines and recommendations outlined above, you can help to prevent electrical accidents and to protect yourself and others from harm. If you are ever unsure about how to perform a particular electrical task, it is always best to consult with a qualified electrician. They can provide you with expert advice and guidance and can help you to ensure that your electrical installations are safe and code compliant. In summary, safe and code compliant electrical wiring requires attention to detail, a thorough understanding of applicable codes and regulations, and a commitment to safety. By following the guidelines and recommendations outlined above, you can help to ensure that your electrical installations are safe, reliable, and efficient.